back to the ESiWACE high performance data analysis and visualization course. Today, I'll show you a bit more, well, step by step, how to work with Paraview. And tomorrow, Donatello and colleagues from CMCC are going to take over and continue with data analysis. I have prepared two things. One is taking sea surface speeds and turning them into an image that then gets clouds overlaid. So you have like a nice Earth with atmosphere and ocean data running at the same time. And the other thing is a bit more complex. That's from my previous life doing paleo modeling. And there we take ice sheet, isostasy data, iceberg melt, vegetation, river runoff, and we can put it all on one Earth. It's technically very similar to the other stuff, just a bit more doing things. So basically, we start with a clear Paraview, and then we import the ocean data. And I'm using a Paraview that I just downloaded from the web page. So this should really behave like anybody else's Paraview if you just install it yourself. So I have to load the CDI reader. So it's tools and then manage plugins. Choose the CDI reader and say load selected. If you do this, you can also say auto load. That's a good idea if you just download Paraview from the web page. If you have self-compiled Paraviews running around on your system, this can get messy, and auto load is not the option of choice because it kind of fixes it to one version. At least that's my experience. So just load the CDI reader. It's this first step. Manage plugins, load, you can do auto load. And now we go on and we click this open file dialog. And so if you have downloaded the files, you can just choose UV. Either you download them from the Swift browser directly, or you use the make file if you checked out the Git stuff that I posted. Then it's really just running make in the session2 folder. Both work, and we need uv.nc. So we open that and say, yes, we want to use the CDI reader. And we get an Earth with oceans and continents. Okay, and now here in the top menu, we can choose which variable to display. And we switch it from solid color to, let's say, V. There you go. So now we have the meridional ocean currents. And now Nick has done these things with turning velocities into vectors. I'll just use the calculator to compute the magnitude of the velocity. So you click on the calculator icon, you get a calculator that's attached to your UV. You give the result a name, and square root of u times u plus v times v. So we have the uv.nc, we have this calculator, and we use u times u plus v times v. Click apply. So we get the speed, and then we have to select as a variable. I think that's the point where the behavior of Paraview changed at some point. So now we have the ocean current speeds. And if you zoom in a little bit, so for me, that's the mouse wheel, you can already see these rings of the Agulhas current that are kind of traveling towards Southern America from Africa. So we have the UV with the calculator. This is the square root. And now that we've chosen the speed and we're actually displaying it, we can change the color map. For that, we click on this color map with the green dot in the top left. And that gets us the color map editor. And in that color map editor, we see a preview of the color map, and right next to it, there is a folder with a heart. And we click that folder. And now we can choose a color map. And so again, there's a lot of defaults. And going down, the one we want is called blue-green. So we just push BU into the search bar, which is kind of the standard Python color map names. So we use BUGN, say apply, and say close, and we get this color map, which looks much more like what we want to have. And now we don't want it all the way to 1.9, but we just want a smaller range. So we have this arrow thing on the top left area with a C, and that's the custom range. And we just say 0 to 1, rescale, and we get the ocean currents with a bit nicer colors. So one thing you can do now is deactivate the light kit, and I'll actually briefly switch my Earth to be a sphere to show what we're doing there. So in the CDI reader, I can choose the projection, and I'll just go to spherical now, which is a bit weird if you have ocean, but we'll just use the Pacific, which is kind of homogeneous. And so you go on view and you say light inspector. And then you get this light inspector. And what you can do there is basically Paraview assumes that there are some light sources distributed through space. And if you have them, you see that it's a bit brighter here on the top of Earth than down under. And so if I now switch the light kit off, everything is lit homogeneously, which is very sub-ideal if you want to see a sphere, but which is totally fine if you just do a 2D map. So with the light kit, you get 3-dimensional structures. Without the light kit, you get more shiny colors. And if you're just doing a 2D map, it's totally okay to deactivate the light kit and then search for your correct projection of Earth with these XYZ thingies. And now everything looks a bit more shiny. No light kit with light kit. And as things are only in the plane anyway, we're cool. So going back to the properties. So light inspector, just take it off. And we have this image, which is basically it for the ocean. Now it would be nice if we didn't have these gray holes in the continents. So we can add an image as a texture in the background. And I've just used this image from the NASA Blue Marble project. The thing is, what Paraview will do is it takes the texture and puts it basically onto your data. And now we have holes in our data set, so it would also put holes into the image, which isn't exactly what we wanted in the first place. So we basically have to put a white board behind our map. Sources, alphabetical. We can use geometric shapes. Put a plane there. And the plane has dimensions. And of course, we want it to be the same size as our Earth. So we go in this uv.nc, we click on information. And here we see the size of Earth. So Earth ranges from -300 to +300, and from minus, well, here it's 130 because Antarctica is missing, so -150 to +150. And we have to do the same for our plane. So we go from -300 and -150. And -0.1 for the z-axis, so it's a bit behind the oceans. To +300, +150, -0.1. And same here, +300, 150, -0.1, up, negative. And what did I do? +150. Sorry, this works. Okay, now we have a white board behind. And now we want to do a texture map to plane. And so we go on filters, and we can just search for a filter by starting to type its name. So we just type texture, text for texture. And we can map to a cylinder, to a plane, or a sphere. In this case, it's a plane. So we do texture map to plane. So now we come to the texture map to plane. Well, that's not finished yet. So you have to add the texture map to plane, and you have to click apply. And once you've done that, you can start searching for texture in this search box in the properties menu. And then it says texture none, and you can load a texture. And you load the world topo, whatever file. So I already downloaded that from another web page and made a small version of it. And if you load that, you get the continents as a photo. And if I remove the calculator, you only see the NASA image, and with the calculator, you see the NASA image where there's no ocean data. So again, texture map to plane, hit apply, search for texture, and then in this texture menu, load the world's topo, whatever. And one thing you can do now is switch to a camera parallel projection. And so I'll just try to demonstrate what this is actually doing by moving my Earth a bit. So now what we have is kind of floating Earth. And even if I go to a perfect flat view and increase this a bit further, it's a bit too much. At some point you see that Yeah, you don't really see it in this resolution, but the things don't really line up perfectly because of the three-dimensionality of the perspective. And so one thing you can do is switch to camera parallel projection, where they line up a little bit better because you're just viewing things from infinity. Again, it's just a detail, but it's a detail you can do. And if you have like tricky, fine-grained structures, it might help. Now we can choose the background color. And for the background color, you can just select anything in your pipeline again, and you type background, and you can choose any color you want. I think a pink does a good job here. While it might not be the obvious choice for your talk, the top corner in the back right is basically because in reality, the whole northern part, well, the whole polar areas are much smaller than they're in the projection. And for the triangles that go across here on the 180-degree line, we just toss them out instead of messing with whether they belong to the left or the right or to both sides. And so we get these little corners. If you switched to a Malweide projection, you wouldn't have them. And Niklas has implemented stuff in the new version of the reader where you can actually put them on both sides, and then it looks nicely. But here they just get tossed out. I think it to that side maybe. It's an artifact of handling the 180-degree line, but it's a pretty robust way of handling it. So now we have an Earth with ocean currents and everything in front of a pink background. You can also make pink your permanent background if you go into the settings of Paraview, but I guess most people won't use that as their first choice. So next step would be adjusting the color bar. And to do that, you go to the color map editor. So you click this. You click the calculator first because you want to adjust the color bar of the calculator. And then you choose the color bar with the green dot. And there you choose this color bar with the E for editing, I would guess. Yes, and René is very correct, and save your state from time to time. It's a really good habit. So what do we want to do? We want to call it ocean surface speed. Meters per second. And I'm always annoyed by this 0.00 plus 00 here. And so we go into the extended options with this, with the gears logo in the top right. And then we get a range label format. And we just put %.0f. So it's a floating point number with nothing behind the point. And then we can just hit apply to see if it actually did what it's supposed to do, which it did. And once we're fine with that, we can say, okay. And now we have ocean surface speeds in meters per second. And we can drag the color bar a little bit up, drag Earth a bit to the left. And we have a reasonably nice image. Okay. Now, if you want to do any exports, it's much easier if you fix the view size. So you just go in View, Preview, and do a preview for 1920 by 1080, so for full HD. And what it does, it says it doesn't, the preview doesn't fit on my screen right now because I'm showing so much other stuff. So it actually shrinks the preview to still have the correct aspect ratio. And now with the pink, you really see what is going to be exported. And yeah, here we go. So that's where the pink comes in really handy. If it was just gray on gray, you wouldn't see it that nicely. And this way, if you put any text or other such elements into the view, you know that they will be shown at this size in the export as well. So if you do a screenshot or a video export, you will get exactly what you see here in your file at the end. And finding this option has made my life so much easier. So I highly recommend doing it. And once we have that, we can say export an animation. And before you do that, save a state file. Oftentimes when I start exporting an animation, I figure later that I did one little mistake and maybe the computer crashes while doing it or something else happens. And I want to go back to that state that belongs to the video that I started generating. So file, save state, and whatever we call it, ocean currents. And one thing you could do if you want to is you can also save Python state files. So you get a Python script that you can run with Paraview's Python engine. If you do that, save the normal state file anyway, the Python export is not as stable as the standard state files. So just save both in case one doesn't exactly behave the way you want it, you still have the other one. So save ocean currents. And now we can say save animation and call it currents. And it already knows we want to do 1920 by 1080. And we can just say OK. And it will quickly save that animation for us. And now I can do. Did I save it here? Yeah. So I can just say open current.png and something will happen. And I have these files, so I can run through them. And if you run through them, you can already see that there's something moving. And what you can do then is you can convert those files to one movie file. And I've provided an example for FFmpeg here. So if you save that file as ffmglob, you can run first CH mode on it. And then you do ffmglob currents.png mp4. And somewhere it will open. Yeah. And now I have an nice little animation that I can use for my next talk. So if you're using the DKRZ supercomputer, you want to run the FFmpeg stuff on one of the GPU nodes, because that's where there's the best FFmpeg. Okay, that's it for this part. Yeah, so the image gets generated for every time step, and they get saved to separate PNGs. In principle, Paraview can export to movie files, but you don't really want to do it. Especially this way, you can still edit the PNGs, or you can do the export in 5 bits and just run FFmpeg on all of those 5 sections, or do a lot of other things. It's a lot more stable and user-friendly if you do it in separate things. What I forgot to do is get rid of this stupid axis logo here. So you could do that by clicking on the eye with the axis. Okay, so next thing is putting the clouds into the story. And now things are going to get a little bit repetitive. So I might go a little bit faster. Just shout if I'm going too fast. So we load the cloud eyes vertically integrated, and cloud liquid vertically integrated. With the CI reader again. And that name already tells you that I cheated a little bit and ran a bulldozer over the time axis of this file to get it to the same units as the other file. That's very useful if you have different inputs in Paraview. So it was basically this. I just use NCKS to copy the time axis from one file to the other. So we load this, we say apply, and now we have this white in the continent, which is of course not what we want in the end. But we ignore that for a moment. We could check cloud liquid or cloud eyes. So there's a little bit of data here in the tropics mainly. There's a bit of water in the clouds. What we want to do again is apply a calculator. And I have this expression here. I'll just dump it into the chat as well. Which, no, not into the search box. So we call it cloud, or actually call it alpha, and put it here, say apply. And now we get nice cloud fields, somewhere between 0 and 1. Still not looking the way we want them, but never mind, they're there. And now we can adjust the color map. So what we do is we rescale the color map. No, custom values from 0 to 1. And now we take this center point here in the We have this triangle thing, and below it there are 3 points where there's actually data that's describing this color map. So it's really just a blue value, a gray value in the middle, and a red value at the end. And our aim is to just turn it into a white thing with a ramp of the transparency or opacity. And so we just take out this middle point, we click on it, we hit backspace, it's gone. Now the color map is just blue to red. And if you click this gyro symbol here, you get some extra info, and you get the color transfer function value field here. So you need the gears, and then you get these numbers, and you also get the opacity numbers. And we change them so all these numbers become ones. Just click on them a bunch of times, and you get the most colorful cloud fields in the process. And once they're all one, we have a white cloud. And we don't want the full cloud to be fully white. We just want it to be 80% white. So put this to 0.8. And you see that this goes down a little bit here. And then we enable the opacity mapping for the surfaces. And while my instructions say that it should look like a beautiful Earth with a lot of clouds, my reality says it doesn't. But we can fix that very easily in the properties. So if you go to the properties and you say translation, put a 1 here. You still don't have clouds. There. For some reason, they don't win against the ocean currents. It's interesting. I did yesterday. That could be. Thank you. Yes. Somebody was stupid. The ocean currents. Oh, the UV. Zero. Here we go, clouds. Beautiful. Yeah, so now you could, again, save the whole thing and see, here's one cool thing you can do. First, you get rid of the color legend for the clouds, because we don't need this 0 to 1 for the clouds. And then what we can do is we save the color map as a preset. So we go to the color map editor for the clouds. So clouds are active, color map editor, rid of the search, and click save to preset. And we can call it cloud white test. And say OK. And now we could search, and there's a cloud white test. So the next time we want to do clouds, we can just load cloud white test, and we save the messing with the color map. That's probably it. Yeah, save a state file so you can load it later. Nope, not about Chrome. File, save state. Ocean with clouds. And that's basically it for this. So that's my second example, or my first and a half. The other thing we can go into now is totally different setup. Ice sheets, oceans, and all that stuff. So this is a visualization that I used to promote the work that Max Planck. Well, when it still was at Max Planck, I used it to promote my work in Palmot, and all the other Palmot people are still using this setup for promoting their work at conferences. So it's not just a toy example, but it's really from the day-to-day work. So what we do first is, so what I did before doing this is a whole bunch of pre-processing the files. I'm not going to go through all of that now. I have scripts for doing that. There's a few things for transferring the time axis. If you have files that have the same number of time steps and that are both float or both double for the time variable, you can just use NCKX and NCKS to override one axis with the other. If you use the standard netcdf reader, which we're going to do now, so we're not in icon triangle land any longer, you shouldn't have negative values in your time axis. Took me a while. And for this example, we're going to extrude the topography. And for doing that, you want to have the topography and your real data in the same file with the same resolution. So there's a bit of remapping involved. And in MPIOM 2D files, you need to set the vertical axis to surface. Just a few little things that can cause a lot of joy. So what we do now is reload the vegetation ratio max file. So section 2, vec ratio max. And this time it's not the CDI reader, but it's the netcdf reader. Say OK, go on properties, click apply. You get a sphere. You can say vec ratio max, and at least you get a land sea mask already. And now we load the color map that we want to use. So click on the color map editor, click on the heart, and GR4L, linear green, apply, close. Now this means that things with a lot of vegetation are yellowish and no vegetation is dark green. We don't want that. We invert the color map, so there's this black and white thingy symbol here in the middle of the colors, and we can simply use that. So there it is. And now the thing is that this color map, properties. So what happened here is we loaded the file, but if you look at the color map, you see that values are going from -9 E33 to 0. And -9 E33 is not a vegetation of -9, but it's just the missing value. So you click on replace value with not a number. And then it changes that, but we still have to adjust the color map again. And we can just say rescale it to the visible range. Or you can use the custom and say 0 to 1. And now you have a plausible vegetation map. Europe is pretty dark green, Sahara is bright, and the ice sheets are pretty bright. Now what I did was I didn't want the darkest dark green. I wanted a little bit lighter color for that. And so I hacked the color map. And it's a little bit messy. But what you can also do is now just, I've described it. So if you want to see how to hack the color map, it's here in the instructions. But I think I've provided the color map with the example. Let's see. Color map editor. Choose a preset, and we can say import. And there is VRM edited.json. So it's color map editor, import VRM edited. Click OK. And probably call it something like vegetation. It's one of these. Let's assume it's that one. Say apply, close, and you get brighter green. So, okay, I'll wait here. So who's got vegetation on a sphere with a light green color map? Should both be in there. So we've loaded the vec ratio max file. It's interesting. For me, it does contain both. Yeah, it should contain topography at a high resolution, but it should also contain the vec ratio max at the same resolution. It should contain both variables. Not CDF-CF. So I'll just go through it again. So you say open. You say vec ratio max, and you say net CDF reader. So for me, it's the one in the middle. And then you say OK. And you go to the properties, and you can say spherical coordinates, replace fill value with none. And the rest should be the way they are. You then hit apply. You should get a sphere, and you should be able to choose vec ratio max. Output type. Doesn't look good. That would be a 2D image. Linear. Rectilinear looks weird. Structured is the sphere we want. Unstructured is also fine. Did anybody get the vegetation correctly? Or am I the only one who's getting this? So there was a bug in the if you have Paraview 590, you only get the first variable. If you have 591, you should be clean. So maybe it's that I have 591. Yeah. Good point. Thanks for debugging. Well, you could just use TopG. If you have TopG, we're fine, and you can just use TopG as coloring. It also works. Looks a bit different, but it works. So that would be the game with TopG as vegetation substitute. And again, so to invert the color map, you choose this black and white symbol. And to load your preferred new color map, you go to choose preset, import, and then use VRM green for edit. No, you use VRM green edited, of course. VRM edited. So use that one. And that should hopefully be this. No, it's a different one. Okay, so, well, we can also just go into the hacking the color map a bit. So basically the color map's just a JSON file. And in the top, it specifies the first and the last point. So we're going from 0, these numbers, to 0.67 and these numbers. And then there's RGB points for the colors. So 0.0 has red, green, blue. And I think it's a potential alpha value. And that goes all the way down to the last 0.67, red, green, blue. Yeah, so it's only RGB, red, green, blue. And you can edit these to any numbers you want. And I think I forgot to do one editing here. So hack the color map. The last should be 0.118, 0.5, and 0.25. Save. So I'll update the example data. And now we can load that again. No, not save. Zip, import. Vegetation. Now we get a vegetation. Now we get this picture. So now we come to the cool part. We want to have a 3D geometry for the whole thing. So we'll do convert cell data to point data, because TopG now is a cell thing, but we need it on the corners of the cells. So we need it as point value for the extrusion. So what we do is we take it, we go filters, search, cell, point, and we get cell data to point data. And we just say yep. And we want to pass the cell data. Okay, so click on those two. And we can again color by TopG or vec ratio max. I'll choose the vegetation now. And now we can attach a calculator. So the calculator works on point data now. We have to make sure that it takes the point data. And then we can say coordinate results. So choose point data, choose coordinate results. You can call the results coords. And here's an equation for the calculator. And that's really just taking the sphere and scaling it up by 1 plus the topography multiplied with 100 and divided by radius of Earth. And if you do that, you get an error. At least by now, Paraview says it's got something in position 61. You can either count positions or hope that it's something trivial. Yeah, there's an open parenthesis there. So no, it's not. Wherever that comes from, but it has to go. And now we have a three-dimensional Earth, and we see mountain ranges and ocean valleys. So there's two options. If you click on the vec ratio and then at the calculator will take the data straight from the vec ratio max, which is not what you want, but you have to click on the cell data to point data and then at the calculator. And then it will get its data from cell to point. And if you do that, the calculator has all of these. And if you attach it to vec ratio max, the calculator only has the two variables. or as point data, it only has the coordinates. So you need the cell to point in the pipe and then attach a calculator. Now we have the vegetation. We can load the icebergs. So similar story again, open the file and we use FRIV. Again, that's CDF, the CDF reader, not the CDI reader. And for safety reasons, we say replace fill with nan. Load. And we say color by freshwater input. Oh no, that's rivers. I'm stupid. It's rivers. Sorry, load the iceberg data. When load surf FV out. Surf with freshwater out. That's the F reader. 0 to 1. Apply. Surf F freshwater out. Yeah, that looks more like icebergs. Now we go to the color map editor and we say use the log scale so we can actually see all the icebergs. And we say we want the color map blues. Apply. And we can invert that color map again, and then we get this color map of freshwater release. And that's actually it for the icebergs. So once you have them, you can move on to loading the ice sheets. So we load PISM Northern Hemisphere and NetCDF reader. And we get this patch on the Northern Hemisphere. And once you have that, you can again attach a calculator. And now we don't want to type the equation and all the stuff, but we can simply choose the first calculator, say copy, use the second calculator, say paste, and hit apply. And then we get a lot of errors because in this file, it's not TopG that we want to use, but iSurf. Hit apply again, and you get ice sheets. So say color by surf mag. Go to the color map editor. Use logarithmical scaling again, and we get kind of nice colors. So you first have to add the calculator, and then you can paste the properties to an existing calculator. It's a little bit surprising, but that's the way copy and paste works in Paraview. Last thing you can do to this ice sheet is to give it other colors. And again, basically it's loading a color map, empty the search box here, click import. And there's a color map that I call Renault-ish with white. So Eric Renault kind of set a standard for coloring ice sheet flow fields. So I just named the color map according to him. And then you get it, and you can say use preset range when importing, and then it will use the range values that you used when you saved it. Then you say apply, close, and you get these colors on the ice. You can still change the range later and say you want it up to 10,000 instead of 3,000 meters per year. And then they're a little bit more whitish, or you can use a log scale, and they get a little bit more psychedelic. that's how you give them colors. So in this case, we didn't have to use the cell data to point data filter because there are no corners associated with the fields in the ice sheet data. I don't have the grid corners, and so Paraview only does point data from it. Just as an explanation why we don't use that extra filter there. So if you click on the variables, you see they are points. They have a point here, so they are point data. While if you click on the vegetation ratio, they have this little cube or whatever it is there, so they're cell data. What we can do now that we have point data is to display ISO lines on top of it. So we click the calculator for the extruded surface, and now we click these ISO surfaces, the contours, and that gets us this menu, and we want to contour by delta TopG, which is the deformation of the bedrock at this place. And this is the range that Paraview suggests. We just remove that. So click here, delta TopG. And now we have this ruler here. And with that, we can say for what range we want to have those. And we just go from -1000 to +1000. And while we're typing that, Paraview already says, okay, these would be the numbers you get. And we're like, yeah, no, we want 21 steps. And then we get 1900, 800, 700, and so on. We can just generate the range. And we also want to show plus and minus 50. So we hit plus here. And now we zoom down here and we say minus 50. Not the time plus 50. Up. 0. And now we have ISO surfaces for anything between negative and 1000 and for negative and plus 50. And we can say apply. And Paraview is so friendly to remove the ice sheets in that moment. So we have to click the calculator again to get them back. But then we see thin ISO lines shown on top of the ice sheet. And now we want to have the lines a bit thicker, so we just search for line in the properties of the contour, not of the calculator. And we can put in 5 as line width. And now we get nice thick ISO lines on the ice sheets. And again, we can change the color map. Change the color map to BRBG. Say apply, close, invert. What did I do? Invert it and choose a custom range of -100 to +100. So rescale. And that gets us these ISO lines on the ice sheets. Now this is super nice, but the ISO lines end where the ice sheet ends, which is of course not what we want. Just have to click back here. So what we can do is we could also add the ISO lines to the bare land. We just have to load Wilma. So Wilma is a solid Earth model. So we load the file for that with a netcdf reader and properties. Load the file. We need a cell data to point data again. So now we can just choose it from the recent filters. Cell to point. Apply. And filters recent. The calculator to get it to 3D. We can copy the properties from the other calculator. It should be okay. And to this calculator, we can then apply. Yeah, there was my Paraview. Thanks a lot. Save your state files, save your state files, save your state files. So I'll just cheat. No, file, load state, iSheet complete. No, don't use the search in a specified directory. Time session 2 is correct. Load. And we should be getting the whole thing. Oh, it looks a bit messy because the screen is a bit small. So here we go. So you can, where's the Wilma? You can keep repeat doing these things. You have the Wilma file, you have cell to point, you have the calculator, and you have the ISO contours. They are just copy paste from the others. Yep. I'm actually going to quit it now for today. All the other steps are described in this document where you have the link. So feel free to actually continue it all the way through. You're most invited to point out any mistakes we made in the instructions or any things that don't work for you. Just send us a message. I'll update the document as I get error messages. And I hope that you kind of got an idea for how to actually work with Paraview. So it's a bit of a learning curve. There's a lot of little pitfalls you can fall into. If you have trouble, don't spend days on sorting it out. Just send us a message. Give us the screenshots of where you are, and we can help you sort it out. We can just do a Zoom call and debug things. Usually it's pretty easy once you're used to Paraview. So I hope this was helpful in getting a way into Paraview and doing fancy images and videos with it. Yeah, contact us for anything.